All right. Looks like we're live. Hey, Sonny, how are you?
I am good. I'm good. How are you, Ted?
Good. It's great to be here. Beautiful day here in Canada. A little cold, a little chilly. We're about to see our first winter, one of like 3 winters we usually get. They come and go. So it's finally spring, late next year, but we're here. Yeah, I think you're in San Diego, right? At the Autodesk University conference.
Correct. Yes. It's a very good event. It's very interesting going on, and we've seen lots of interesting use cases and potentials for LiDAR and AI.
Yeah, well, it's probably the perfect crowd. They really understand what this all is about. So I can't see a better fit than that for you. So I hope you have a great time there. But let's just dive in with what we're going to talk about today, because we got a lot to cover, and I don't want to waste any more time. And before we really dive in with details here. Okay, so Sonny, you and I met like 4 months ago. But give us just a quick little intro about yourself and your journey.
Yeah. So I'm Sunny. I'm in the head of international sales for XGRIDS. And then before this, of course, I used to work for DJI. So I have 6 years experience in DJI, more on the enterprise sales side as well.
Yeah.
And right now, of course, I basically head over everything that's international. We're kind of starting the international expansion for XGRIDS.
Cool. Yeah, I mean, you were at DJI in the beginning of things, right? So a lot has changed since then, and you were there, I think, probably like Phantom days, like early Phantom days.
Yes, definitely. Good old days.
Good old days. Yeah, I mean, that's the drone that changed everything, and it's still very useful even for a lot of people today. I'm not going to bother introducing myself. I think most of the people that are on this stream probably found it through my page on LinkedIn. So I'm sure you're semi-familiar with me. If not, you can find both of us on LinkedIn. That's where we spend a lot of our free time, unfortunately. But it's such a great community. So just reach out, send us a message if you want to learn more about what we do. All right. So SLAM, what is it? We've heard it. There's a lot of misconception. I think there's a lot of just complexity behind it too. The reality is that SLAM is not that new. This is a clip that I generated in a software called Synthesize. This software is very useful for camera tracking in post-production and in your movies and visual effects. And it's essentially what SLAM does. It's feature tracking over time. And by assigning these world coordinates to these features that are tracked frame by frame and holding them, consistent throughout each frame, we can essentially figure out where the camera was as it moved through that trajectory. And so you can see the camera position overhead at the top view, front view, left view. And this is SLAM in a nutshell. So it's simultaneous localization and mapping, meaning that both these things are happening at the same time. Localization is where am I, and mapping is what's around me. And not much is really all that different when it comes to SLAM when we talk about it in the context of laser scanners. With laser scanners, they're really only seeing points and distances. And so it's more about matching the geometries and not so much matching those features that you're visually represented in a RGB pixel. The thing about the laser SLAM and my experience with it is that it's a little bit, it's a little bit trickier, especially around areas where you have very tight corners, such as going through a doorway. You have, staircases, interiors. The kind of places you'd like to use SLAM, honestly, are sometimes a little bit, the more precarious situations for it. It's improved a lot, and of course, this has been ongoing technology and innovation in this field quite quickly, especially with the rise of autonomy. But the first principles of it still stand, and so anything that improves this or makes this easier is just going to translate into making the data collection almost carefree when you're working with these devices. It's not rocket science, though. You don't really have to think about it. You just have to essentially plan and have an idea of how you're going to be moving through the space in order to have that SLAM algorithm really work well for you. XGRIDS, you guys came into the scene fairly recently. I think you're like a fairly new company at 3 to 4 years old, I believe.
Correct.
And
yes. We're only 4 years old.
Yeah, only 4 years old, and there's a lot of R&D that happens before any of this even makes it to market, I'm sure. So I think one of like the most impressive aspects of using your scanners and trying them out was just how robust the SLAM was. I never really got it to fail. And you provided this schematic that kind of outlines the framework.
Yeah.
And so what I see here is that we have the camera-based SLAM that's in the scanner itself. And then we also have the LiDAR, right? The laser head. And those
Sure.
are both being fed into this SLAM algorithm that's essentially over here. And we're getting features and lines and all those points from the images, and then all the geometry features from the LiDAR. And those are being fused together. But what I saw here that was also very interesting was that there's actually some, neural networks at play here behind the scenes as well. Can you give us a little bit of a breakdown on like what's going on and how this is different than other traditional forms of SLAM?
Sure. So essentially, we are trying to go. So, like you actually mentioned there just now, different type of sensor, different type of SLAM has its advantages, and naturally, there's challenging places or scenarios that do come across. So, we kind of with our algorithm, we try to put them together naturally, and then to overcome the some of the challenging spaces for just the individual sensors. Now, of course, it's not just about you put everything together and it will work. Of course, we need to fuse them correctly and actually make sure that all the position information and it's precise to relocate all the different sensor and all the information. But with that basically allow us, so in like scenarios that's challenging for a simple LiDAR, then we hence using the visual SLAM part of it
Mm-hmm.
to overcome that, and then vice versa. If it's anywhere that's visually it's hard, then we use the LiDAR part piece. And then
Mm-hmm.
together with IMU and then with GPS with RTK, that gives us a very good data at the end of the day, and then also a very robust outcome.
Yeah, and so the IMU is always there. It's it's a
Sure.
sensor, it's a measurement sensor that's built in. The GPS may not be though. Like you may
Correct.
be working with the scanner. I know I never had a GPS antenna hooked up to mine when I was doing any of these captures. So that's an option if you have
Correct.
GPS. If you're outside with these the types of scanners, these handheld scanners, I would use it if you can. It's always going to make things better. But you don't need to. And I think that's one of like the big features of SLAM is that you can go between GPS denied and GPS available locations and have that intelligently sort of carry over and interpolate positions. I did all of my scans, the majority of them indoors. For me, when I think about that, it's the first thing that that comes to mind is this going to be dimensionally accurate? Like,
Right.
our measurements going to be possible out of this? But I guess the robustness of the SLAM really plays a big role on how much you can depend on those measurements at the end of the day. Another thing that this makes a difference in is in areas that you're scanning, which don't have many features, right? It's just like with
Correct.
photogrammetry. If you have a set of photos and it's a plain white wall, it's not going to work because there's nothing really to tie them together.
Correct. And this is where actually the visual side actually comes in. So that assists on the positioning and then getting the data, and then still get a robust data afterwards.
Yeah. So you mentions here that if you have GPS, you get continuous absolute coordinates. Even
Correct.
if you head indoors and you lose GPS tracking.
Correct.
But you should also be mindful that it's not like continuous forever. There's still a little bit of
Correct.
drift that's going to occur over time. So you need to get back out there and reacquire those satellites at some point. What have you found is like the limits with your scanners?
Yeah. So I think as long as you keep the disconnections within the 100 meters, then we should always be able to get the georeference data afterwards.
Right. Right. So 100 meters, it's more of like a distance measurement, not so much time.
Correct.
In my experience with this, I was walking at a fairly normal pace. Like I wasn't slowing down or anything like that.
Yeah.
But if you're using the app, and you'll see it in a little screen recording that I have coming up next, it actually does show you how much distance you've covered. So you can use that as an indication of like, oh, maybe I should, head back outside and tighten this back up before continuing the rest of this indoor portion.
Correct.
Yeah, that's really useful. So here's my experience. I had a chance to test both the Lixel L2 and the K1. I received these from you guys about 2 months ago, and I've been bringing them to different job sites, different locations that I find myself working in. Not specifically doing this at those locations, but I'm doing something else there, and I have these with me, and so it's a great opportunity to test them. Just like with everything else I test from different manufacturers, there's no sponsorship here. Like, you guys don't pay me to do this. My only condition is essentially, well, my condition is you don't pay me, because that's, it's a very slippery slope for me. I don't even get involved with that at all. But my condition is essentially, let me borrow it. I'll send it back, but you can't interfere at all. Let me figure it out. Give me any kind of support that you would a regular customer, but no extra hand holding or, a special treatment. And so you guys were really great at that. And I had a lot of fun with these two. The one that really I loved at the end of the day was the K1. And so that's this little guy. It has the LiVox Mid 360, which is the laser scanner. And very interestingly, that scanner, if you've kept up with LiDAR technology over the last few years, this is a very new entrant to the market. And it's not really meant for mapping. It's you're not going to find this on a drone or anything like that. And all the marketing material from LiVox, it's on an autonomous vehicle or autonomous robot. So it has a very short range, but it turns out that 40 meters, that laser range, is actually perfectly fine for most of the scenarios you're going to be using a SLAM scanner like this in. You're going to be indoors. 40 meters is a huge space for you to not have enough coverage in. And I scanned a very large hangar. I had no problem getting points on the ceiling and all across this facility. But what's really cool about it is that it's the form factor. I can't get over the fact that it's just this little tiny thing. I don't have to worry about battery charges. It really just has one in the handle, and the camera is built in on both ends. And you can see the smaller sensor here. They're on both sides. This is the SLAM, I guess what you guys are using for the multi-SLAM between the laser and the camera. And then this large sensor here on both sides is what's creating those Gaussian splats. The L2 is a step up from that. The biggest thing that I noticed is the range. So if you are doing outdoor captures and larger areas where you do want that reach, then having the laser head that's on here, the XT16 from Hesai, gives you that range. And there's a lot of flavors of Hesai Pandar scanners. I feel like 120 is more than enough for this type of category. I know that they have one that does up to 300 meters range, but again, 300 meters is so far away. You're not going to really be scanning anything or need that data. So it might just be producing too many points in the first place. But it's a very robust unit, and both of these, the compute is built right in. So there wasn't a sort of a backpack or something that I had to carry additionally. It was all just in this little package for both of them. And you can see here the Insta360 1-inch that's also fixed to the top on the L2. And that one was optional as well. If you want the Gaussian splats, my understanding is that you need that Insta360 attached to the top. But if you just want colorization, then the colorization can happen from the built-in cameras that are in here as well. Am I right about that, or am I
correct?
Making
That's
that
right.
Sweet. Yeah. Cool. So here's a little clip of what it looks like on the iPhone app once you get started. And so just like any other SLAM scanner, you place it down, let it initialize, let it do some scanning and find its bearings, and then pick it up and walk. You do get a nice preview of what the visual camera sees. And this is what I was talking about earlier. The distance you've covered is up here, your velocity. And what does this indicate? I couldn't really understand how this was factoring in.
It's more like a LiDAR quality, essentially. So the characteristic that it's already getting. So usually green means it's fairly good.
Oh, okay. So if you're going in a scene that maybe a little bit more demanding from the SLAM algorithm perspective, you may see that drop to like an orange or a red.
Correct. Yes, and then that's basically the time where the the visual slant type part will get fired up.
Oh, okay. That's good to know. Really cool. I like that. I like that real-time feedback. But to be honest, after a little while, I got really comfortable with just knowing that the scanner was going to handle the situation. And I started just using the push button operation. So there's a button on the bottom, and all you have to do is double click it, and it starts flashing, and then you're good to do your scan as if you were monitoring on the screen. And I ended up doing that for like 90% of the scans afterwards, because it was just another layer of less things to pull out and set up before I started walking with it. So after that walk is done, choose your own adventure, essentially, what you want to scan, and cover everything you need to with the kind of density and overlap that you want. On board, on the device itself, in the storage, you'll find project folder, and I found in that project folder 2 LAS files right off the bat. So one was named color and one was named map. And opening them up, I saw that the color was obviously the colorized point cloud. So colorization is happening in real time. And it had 14.7 million points within it. And then the second version, named map.las, had 46.4 million points. It wasn't colorized, though. So more points here in this real-time point cloud. And I'm assuming that that's because the points in the colored point cloud that couldn't sort of be path traced to a pixel coordinate were discarded. Am I right about that?
That is correct. So basically, we're only leaving the points that's being colorized, so keeping it the whole data clean.
Right. Yeah. So just because it's going to be points that are colorized and then points that are just nothing. And so that makes sense. You would just discard those. Both of these were on the same exact coordinate reference frame. If you open them up on Cloud Compare or another LiDAR tool like LiDAR 360, they would just fit right in. So if it's essentially a duplicate of the data, it's just one of them has that colorization, the other one doesn't. And I'm going to go through some of the sort of assessment of these points next. But I was really surprised by the quality, especially the fact that there's essentially no post-processing other than what you're going to be doing for the project and what your deliverables are here. The trajectory is there as well, and it's just ready to go. So in some cases, this may be good enough. Like if you're doing forestry work, I suspect that this may be good enough, especially if you have RTK on the equipment and you have geopositioning in real time as well. I think you can probably just skip the other type of processing that you can do here. Here's the point cloud. Here's the uncolorized one with 46 million points. And you can see in this profile section of this tree that it's quite dense. Like there's a lot of density here. I've used other SLAM handheld scanners. They all typically produce some sort of real-time result. But I always find those results to be something that's just like a thumbnail, essentially, like a quick little preview of the point cloud and not really meant for use. So they're typically like very sparse. And I was surprised to see here that like the full geometry of the tree was there throughout the entire scene. It looked like what you sometimes see in a fully processed point cloud from a scanner. There's obviously a little bit of point smoothing occurring, but it's done tastefully. Like it's not aggressive. It's not like completely obliterating corners and edges. I'm generally not a huge fan of smoothing, but because it was just lightly done, just a little bit of tweaking, I'm okay with it, and I think it overall improves the quality of the data. And some other geometries that I found interesting is that it's quite precise from the real-time point cloud. Again, this is like the point cloud that was just on the SD card on the L2. Just copy paste open on your desktop, and this is what you get. So you can see the geometry of these support beams, these I-beams up there. Probably good enough for line work, I would say, depending on what the project specifications are and what the requirements that you're dealing with. But you might be able to just skip a lot of that post-processing that would be typically required to get to this point. Looking at some precision, of course, like SLAM is never going to be as precise as a terrestrial laser scanner. because it's moving, right? Like anything that's moving and trying to simultaneously map and create all this data, there's just a lot more bias involved in those estimates. I'm looking here at profiles, like very thin, I think about 2 centimeter thin profiles of wall sections. And I found that the real-time point cloud varied between 2 and 3 centimeters. So I'm just drawing a horizontal line here from edge to edge on sort of a best fit between these. And you can see 2 centimeters delta X and 2.8 centimeters delta X on this other side. So that's, for a real-time point cloud, I was impressed. This is already a pretty good start, especially considering that there's no other processing required at this stage. But if you do want to have more processing and you want to get sort of like the best result you can from the equipment, then you take that project file and you open it up on your desktop in a software called Lixel Studio. And so this is, if you've used LiDAR sensors before, you know that they all have their trajectory processing software. And they all come in different flavors and features. But essentially, all it's doing is providing you the final reconstruction or the final trajectory, and then the geocoded points along that trajectory. So you can see the path that I took throughout this park. It was actually very busy, a lot of people here. And it did a great job at automatically filtering out any moving objects, such as pedestrians and cars. And you don't see the ghosting effect of those points. And you can see that I did loop close at the very end. But one thing you told me that I thought was interesting with your scanners at the very beginning was that loop closure isn't that big of a deal. You don't really stress it as much as you may have heard of it before.
Correct. So for our scanners, essentially, loop closure is always good, essentially for SLAM technology. But because we're leveraging on the multi-SLAM side, right? So therefore, it's not a requirement that you always need to go back to the starting point. So giving more flexibility in terms of how you would plan your route of scanning. Yeah,
that makes sense. Actually, I see a really good question here. Christoph says post-processing with GCP is possible. And my understanding is yes. I didn't try it, but am I right about that?
Correct. So as you're scanning, we have the feature of, with a single click on the button, you can record the kind of like the check-in points or ground control points. And in post-processing, you can input the coordinates of those points if you know the absolute coordinates, and naturally post-process with those coordinates information and get the whole data georeference.
Yeah, that makes sense. So I think the reason I didn't do it is because when I had mine set up, I have it right here, I always use this tripod handle because I found it like a lot easier to just like hold and then like lift up higher. So there was a base in the box as well that had that target, the little X marks the spot. So you would just place this over the marker that you've already measured. You have that measurement, that coordinate, and then is it like a button press or is it on the app where you make that recording?
Both.
Yeah,
so both, either on the app or a button press.
Yeah. I think GeoSLAM has a similar function. I know the H300 from Green Valley that I've used, similar function. So that's very useful if you have existing control and you want to georeference your data set to it. And in that case, you don't need RTK. Like you don't need to have a connection in that moment in time. So you can see like the point cloud size growing, right? Like 14, 46, 147, 174. And now this is a closer look at that point cloud. You can see a denser, geometry, very similar. Smoothing is still there, but again, tastefully done, nothing too aggressive. I mentioned already the filtering of moving objects and people already done in one step on the go. So there isn't any additional steps you need to take as the user. But this is the final most optimal point cloud that you could generate from this L2 that I had that day. So I'm really happy with it. Here's a look at the distance that was covered in terms of that ranging. And so I'm in the.
Need to bring back the.
Yeah, totally. juggling too many things. Let me go back one step here. Yeah, here's the tree again, much denser, like I mentioned a second ago. And so, that's what we expect when you have that post-processing applied and you've taken that time. Here's a range estimate as well, or a range assessment. You can see that, baseline between the center of the capture area all the way out to the extremities of what's in the data set. We're seeing about 150 meters. Of course, this is not scientific, assessment here. I moved throughout that capture area, so there are points where I'm closer and further away from that building. But what you expect from that Hesai XT16, and like I said, I think 120 meters is more than enough for these types of tools. Here's the wall profile assessment on the precision of these points. And you can see it's been improved. This is the same exact locations that I showed in the real-time result. We have a delta X of 1.1 centimeters on the best case scenario and 2 centimeters on the worst case scenario that I was able to find. Of course, there's definitely areas with more noise or, different, factors, physics. You can't really get away from the way that lasers and light would behave out in the field. But overall, this was a pretty consistent result that I saw in this data set. And I'm happy to provide a link to these data sets after this webinar so people can dive in themselves. The other thing that I was really excited to do is I had this data set from an RTC 360 inside of the airplane hangar at my school. And that was collected over a year ago. And I hadn't really had a chance to use it for much up until now, but I realized I had scanned the same exact location. And so I took the I took the sections from both data sets that most closely matched, that had complete coverage on both ends. And I did a very, very simple accuracy assessment. So I found a corner of a doorway here and just traced the line all the way to the corner of the next doorway. And the RTC 360, which, everyone knows, the scanner is the gold standard when it comes to terrestrial laser scanning. It's an incredible piece of equipment. That pulled out a measurement of 34.971. And doing the exact same measurements as best as I could. Of course, there's a little bit of measurement error here. It's very tricky to pick the exact same location in point clouds. The K1 got 34.98. So just 9 millimeters difference between the two was almost too good to believe. But this is what I got. So wow. That's with no control, no adjustments. This is purely just cutting out a section and point-to-point inverse. So really impressive there. I think a lot of this has to do with just your path and how you complete the loop and how the SLAM quality is throughout the scan. But from this example on my end is really the only data set that I had that was comparative with an RTC 360. I was really impressed. And again, that was with the K1, which has that mid 360. This scanner really blew me away. This laser unit really impressed me. I've seen it come up more and more, and I didn't really think of it being able to achieve these kinds of results. But the overall system accuracy here has a lot. We got to give flowers to that. It's really impressive. Happy to share this as well for anyone that wants to do their own assessment. Of course, precision doesn't really come close. Like the RTC 360 is just a beautiful point cloud. But again, one of them you're walking with in your hand, and the other one's on a tripod and costs $90,000. So then finally, the fourth deliverable that is possible is the Gaussian splats, right? Like what we're all here for. That is done through LCC Studio. So that's another application that you guys created on your desktop. And the workflow is the exact same. You take the project files from the scanner itself, open them up in your desktop on LCC Studio, and select the quality level. It's like 3 options, and just hit go and wait. Gaussian splats are, they're a novel view synthesis. There's AI training involved here. You need a GPU. and it does take much longer. It's not really comparable to LiDAR processing, but the result is really, really incredible. And this is kind of like one of those cases where every time I saw a Gaussian splat, I was like, wow, this is amazing technology, but I can't really see a situation where it's useful in a, in an engineering or construction or, geospatial format, because it's very difficult to get scale right, to get accuracy right. And we'll talk more about like what goes into this, but in this result, you get essentially comparable accuracy to the LiDAR data. You get that built right into the Gaussian splat. And I didn't have to do anything else. It was the same exact walk. I didn't have to have another camera with me. Didn't have to build a rig. I didn't have to worry about the aerial triangulation or the photogrammetry process that all Gaussian splats start from. It was just so simplified. And this is like that thing that I think we've been missing to make these novel view synthesis methods that are rapidly evolving and getting better and better, to make them actually useful in the real world, and have users that aren't just tech fans like myself really appreciate the value within them. The LCC creates this file called meta.lcc, but it can also be exported in PLY format. And that is a more universal standard format that you can open up in different viewers and use elsewhere. And then, so here's some results. So walk me through a little bit of what we're seeing here, because there is the point cloud in the back,
right,
but then there's the Gaussian splat in the front. And then the point cloud here isn't like the exact same point cloud that you see when you just process the LiDAR point cloud, right? This is slightly different.
Correct. So what we're actually doing, well, actually, we're the very first in the market to actually develop this SLAM-based Gaussian splat generation. So, originally a lot of what we see is based on visual images, but we kind of incorporate into one is the point cloud, and also our expertise also inside inverse rendering as well. So what we're actually doing is that we first process the point cloud, and naturally that already can feed into the training piece very good structural information as well as post information. So naturally that we do the point cloud processing first. And then of course, with the imagery and the inverse rendering part piece, we also feeding like very high quality, colorized data as well for the training to train the Gaussian splat. So what you're seeing here essentially, so we basically is overlaying the Gaussian splats and the point cloud. But this is basically the point cloud that's being used as the structure and or the post information for the Gaussian splat. So it's naturally not the full point cloud as you would see in the Lixel Studio,
right,
the higher dense version.
Yeah, because I mean, there's no need to have those 174 million points here. We just need the ones that are edges and corners and filling in those geometries within. And I also noticed that there's some points in these splats that are probably not coming from the laser itself, but are points that are generated from the images, because they appear in locations that I know the laser wasn't really able to see, or wasn't able to see far enough, like with the K1. So that's really interesting how this fuses together. It's the first time that I'd seen this technique, and before this I hadn't even really considered it as being a possibility. But kudos to you guys for coming up with this, and I think we're going to see other OEMs and other manufacturers adopt this type of methodology as well, because it's already all there. Like a lot of these scanners already have cameras. They may not be integrated to the point where they need to be today on these generations for it to work this well. You guys kind of have been working on this since the beginning. But I can see future generations of hardware very quickly starting to also incorporate this type of feature, because I think once you see this, it's really hard to say that this isn't very valuable in this field and in these situations.
Exactly.
One of the other benefits of this is just the overall quality of the splat. You just have more initial information about the scene, right? So the inferencing and the training that's involved afterwards generally ends up being of higher quality. I didn't really see floaters like that. That wasn't a phenomena that showed up, and it handled areas where photogrammetry is still involved in splatting. We still need camera alignment. It handled areas that camera alignment probably would have failed or produced, big gaps of data, and handled that very well because the LiDAR was there to support it. Can you give us a little bit of a background on what we're looking at here?
Right. So essentially, that's exactly we're leveraging on the expertise of the multi-slant piece. Like you said, like there's definitely going to be a lot more people trying to put them together, but at the end of the day, it's really the algorithm to be able to, use the data precisely and to align them. And this is basically what we're feeding into the training piece is the better structure information, also the better lighting. So that's actually allowing us to to allow it to train it successfully and then being more robust. Therefore, we are able to do much larger scenes, not just like simple rooms, but in a bigger sites, whatnot, so that you can actually train the data and as well getting the data in a much efficient way.
Cool. The questions are really good here. Derek has one. I'm told you have an integration with Apple Vision. Is this the case? I would really like to see that.
Yes, absolutely. We are working into basically putting our scan data, the Gaussian splat result, putting into Apple Vision Pro, because that would actually bring the actual immersive experience. We'll be rolling out that SDK and kind of a demo very soon.
Got it. Good question here. What's the price of the K1?
It is roughly around 11,000 US dollars. Excluding all the tax and everything, but that's basically the range.
Yeah, and the software that the LCC Studio and Lixel Studio, the two pieces of software that I showed, do these come with it when you purchase the hardware?
Yes, definitely. So the software actually comes. The Lixel Studio actually comes with the purchase of the equipment, and then everything is locally processed. So it's not like a cloud license, whatnot. So it's everything's on your computer.
Oh, I love local. Cloud is great too, but something about just having it forever and having full control of it just really is the way that I like to have my equipment run. Christoph, another great question. Why is the Gaussian splat not computed on the internal cameras? But with, I guess in the L2 case, we have the Insta360.
Right.
On the K1, it is the internal cameras. It's just those larger sensors.
Correct. So for the K1, naturally, we've integrated the cameras. So therefore, we're using all the integrated data. For the L2, because the integrated camera is, resolution-wise, is not as good. So we definitely, still at the end of the day, Gaussian splats still need that imagery data, good imagery data for that. So we leverage on the Insta360. Now, of course, we have launched the L2 Pro, which I think we'll get to. But on that side, we also integrated all the cameras as well.
Yeah, absolutely. Here's in the LCC viewer. So once you generate that LCC or that Gaussian splat, you can also view it. So this is just opened up in another piece of software called Viewer, and that's just available for free on your website. You can have someone like I when I wanted to share this with someone in the beginning, I would just give them a link to that viewer. And then they would download it, and then I would send the LCC file over as well, and they could just open it without any licensing or anything like that. And it operates exactly like it did on my end. But this is the X factor here, is that measurements within splats, getting the full visual fidelity that you get from what we're used to with photogrammetry, but then also having that dimensional accuracy that you are used to with laser. And again, depending on how well you complete that capture, your accuracy could be really, really great. Your mileage may vary, of course. Every situation is different, but in my experience, I grew to trust it quite a lot, and I would probably go as far to say that in some cases you could definitely use this in more specific engineering use cases where the alternative would be very costly or cumbersome to do. This is one that I did myself. So this is a funny story. This is the building I used to live in. I recently moved, and this building has this penthouse, but it's available to anyone to use. There's no one ever up there. And so just before moving out, I was like, hey, I better go and scan this thing before I'm never allowed back in here again. And I did this in about 10 minutes. And I'll show you here. I actually have the data set available. Let me see here. Okay, so I'm going to pull over. Hopefully this works. There we go. So here's the viewer on my desktop. And you can see it runs really, really great. It's a little laggy when it's going over the network here, but solid performance on my end. Hold on, I just noticed I have Christoph's comment still up there. And here's the the benefit of these techniques is look at that reflection, preserved and accurate throughout. So very large scene, a lot of doorways. Thankfully, these are some fairly large doorways with no problem for a SLAM scanner. But there is a doorway here that I was sure was going to fail. And that's as we go through here. This doorway right here, only one of these opens. And I was like, oh man, this is going to be tricky because there's glass everywhere. So, the laser can go through it. The SLAM is going to get all confused. But no, I just carefully walked through and I was in the exterior and continued. And so this was with the K1. And so here's an example of what I said. Like these are sort of like a hybrid points. When you switch into the point cloud viewer, this building is in here. I know for sure that building is beyond 40 meters away.
Right.
So there's no way that those points came from the laser scanner. So these points must have come from the photos. And sure enough, you confirm that. And there's also a skybox option when it's being processed. In this version, I didn't turn that on. But if you do, you have a full skybox and it looks like you're outside. So really, really incredible result from like a 10 minutes of walking, and great dynamic range as well on the on those cameras on the K1. Challenging scenario with a lot of backlight and also indoor light in one scene, and the scanner handled it really well for this result. So going back, here's another example. This is the hangar, and the great thing about Gaussian splats and these methods is that they're very lightweight. Like it's not like sharing meshes and point clouds anymore. This is actually viewable in a browser. So your LCC tool allows you to publish and generate a link, and you can share the link with anyone. And this is the link opened up on my Google Chrome right now. So it's running. Again, great performance. I think it's slightly downgraded in terms of quality, but you can also enable a more detailed version of it. I'm not going to do it right now, just in case my system can't handle it. But I think inherently this is another huge aspect of why these neural radiance fields and these splats are going to make a pretty big impact in the field, because sharing is always one of the hardest things to get right? Like we're creating amazing data sets, but we're still struggling to share them efficiently. I've said it a million times, we're competing against the PDF file format. Everyone just expects things to open in an attachment, right? And so this is inherently different from that, and it works really, really well. Here's the view from the 360 cameras. And another little tidbit that you shared with me is how to hold it. So if you want the best splat, the best result, orient the scanner so that those wide angle lenses, that, that object that you're interested in or that space you're interested in is in sort of center frame.
Exactly.
Can you give us a little bit more detail on what you mean by that?
Yeah, so essentially, because I usually say you want to keep your point of interest really at the center of the lens. So looking at this right now, so if you're keeping it in the middle, you're getting the geometry right, there's no distortion, and then definitely the color, everything is good, the best. So therefore, we usually, you do need to plan your route a little bit and where do you want the best details. And then always try to point the camera at it. So if, let's say, in a corridor scenario, then you don't actually have to kind of turn the orientation. You just keep it as it, because you want everything on the sides. So that's basically a little tip of scanning for Gaussian splat.
Yeah. I mean, it'll still work if you're holding it and these cameras are pointing, to the sides. So, to your left and to your right, which is how they are oriented when you're just holding it normally. But the K1, you can just rotate it like I did here and just held it sort of out like this. And, I was doing that because I wanted that wall to come out perfect. And so I'm keeping it centered. And then I also, just like photogrammetry, at the end of the day, it's very, very similar to reconstruction from images that we're used to. You should attempt different levels, or like a high, maybe do a loop with it up high, a loop with it down low, because if the camera never saw something, it's not going to be able to recreate it.
Exactly.
But the one thing here is that you're kind of like blending the laser scanning and the photogrammetry together. So the operator should keep that in mind. Like you don't want to forget the laser's there, and the laser has its own sort of best practices. But because the multi-slam is always in the background, it's a lot more forgiving. So you have that bandwidth mentally to sort of think about the camera when you're scanning the scene, if that's what you're interested in. But I mean, if you don't want the Gaussian splat from the results and you're just working with a point cloud, then you don't really have to worry about it at all.
And one interesting to point out is that you can see that you in the other lens, if you're oriented sideways like that, you're actually having your the body or the scanner in the picture almost all the time. But that's nothing to worry about actually, because our algorithm can naturally just remove that. As you can see in the model, there's no shadows or floaters whatnot. You actually remove it quite nice.
Yeah, I was really, really impressed by the ability for it to automatically mask me out, because having done this type of work with photogrammetry from like scratch myself, I know that this hurts me to to see a human holding in this wide angle lens, because that to me means I'm gonna have to mask all of this out every frame just so that doesn't get painted into the textures. But yeah, did not have to think about that with this at all. It's all being intelligently done. Probably helps that there's a laser there for ranging, but there's all these sort of things that are coming together here in this package that are working really, really well together. Really nice orchestration. The one tip that I can provide for people as well is if you want more detail in the splat of the result that you're going to achieve, at the end of the day, just move the scanner around that area more, right? So you can see the trajectory around this area with all these aircraft engines. And you can see how I was standing on one of these platforms, and I was essentially just like waving it like a torch, like not like whipping it back and forth quickly, but making sure that it saw all different angles of light, of reflections, so that all of these materials come out as realistic as possible in that scene. And there were certain parts in the hangar where I would go inside of aircraft and make sure that I move it throughout the cabin to capture a really good interior, right? All while thinking of how these images are going to be from the perspective of me, using it for photogrammetry, right? Like if I was using a regular camera and my goal was just SFM, then I would be doing the same thing. So it really applies here as well. And it worked really, really well. Every time I did this, I could really easily spot out differences in the quality of that splat in the area versus others where I just walked by quickly. So again, pick your own adventure. And again, this whole scan was 25 minutes. Like to do this manually or even with a drone would be hours, maybe days to get it at the same level. And then, all the post-processing that's required to get it right. But in terms of the use cases I'm really excited about. First of all, I think forensics is a no-brainer. Like forensics is going to pick this up right away because it deals with so many of the pain points they have. But I'm not an expert in forensics and reconstruction in that field. I have a few people in my network they are, and I hope that they get to test this soon. But in the AEC world, in the engineering world, we have on-site inspections, which 360 cameras are already great at, especially on these periodic walkthroughs of sites. And you're doing the same thing here, right? It's essentially the same thing as walking around with a 360 camera, but you're getting geometry, you're getting point cloud, you're getting the splat all in one go. And then design, right? Taking that same data, because it is dimensionally robust, bringing that into other tools like Revit or AutoCAD, and blending that in with other assets and models in a BIM style. And for visualization, for planning, for design, I can see this opening up a lot of opportunities, and I'm sure a lot of gears are turning out there and building these tools. I know that you guys are building something You sent me this last night, and I brought it into the slides really quick, but walk me through what we're looking at here.
Yeah, so essentially we have just create, this is a demo, but we created a plugin for Revit. So inside Revit, you can directly open up the LCC format, the LCC model, our splat model, and then by just a simple few clicks, where letting it know where the floor is, where the ceiling is, where are the corners of the wall, we'll be able to generate the model directly in Revit, just by looking at the LCC model itself. And then, vice versa, I think it showed a little bit there. You can compare of what's being built inside Revit to the actual splat model. So kind of compare, design and what's scanned there. So that's something that we think it's going to be actually useful, because this is what you would actually see there on site. And then from there to create a model directly in Revit. And then kind of the next steps, this is just a demo, but what we were trying to do moving forward is, everybody's talking about AI, and definitely that's kind of what we're trying to leverage on. Naturally, we'll start working on segmentations and classifications based on the splats. So moving forward, we'll try to get to a point where, we naturally know the floor is the floor, the wall is the wall, window is window. So naturally, with a few clicks, you'll generate the model by itself automatically, and then you can do the editing, and then kind of compare that with the scan data.
Yeah, cool. Wow. Okay, so like even like segmenting things, objects and features, like we're used to segmenting in point clouds, but doing that segmentation in the LCC in the splat, and maybe you want to display just a cabinet or just one section of a location, or maybe just the walls without anything inside the room. That's going to be a more automated. That's really cool. I'm not a Revit user myself, but I commission Revit work from those experts, because it is such a complicated piece of software. But I can imagine that this is really beneficial, because point clouds are still just point clouds. Sometimes they're a little bit hard to tell what's going on, especially if they're really noisy. And I can't see someone not wanting to use this, especially if they can rely it on the same degree that they can rely on their point cloud. Cool. So let's now talk about what you guys just announced. So the L2 Pro, this is it. And I see a 0 and a 1. I see a 0 post-processing. You guys are very anti-post-processing. I love it. But you still give us the option for post-processing, which I'll always take. And then 1 millimeter point spacing. This is kind of wild. It's, we're not talking about accuracy. We're talking about point spacing. So like density, right?
Correct. Yes. So yeah, with the L2 Pro, we just launched this last month, probably 3 weeks ago in Intergeo. So we're not anti post-processing per se, but we do believe in that everything that's more real time and onboard processing will give you actually increased efficiency, and that's what SLAM is doing. It's really simultaneous, right? So what we're actually doing is that we've enhanced the algorithm, we enhance the processing power on board. So once after the scan, you basically will get pretty much the post-process quality of data that you would get from the previous version, but right after the scan. So that's it greatly improve the efficiency of using the data. And in terms of what the post-processing can do, then is about getting the next level quality of the point cloud. So that's where the 1 millimeter point spacing comes in. So looking right here, I think on the right, that's the real time data, colorized data directly from L2 Pro. It's pretty much the quality or even better than what the L2 can get to from post-process version.
Yeah, and also on a hardware perspective, the cameras that were on the K1 for the splatting are also now built in, so there's no more attachment required up here for the 360 camera in case you need that.
Correct. Yeah, thank you for reminding that. Yes, that's a very important one. Integrating the camera that saves the workflow, and then you definitely one less device to charge the battery and to bring and whatnot.
Yeah, one less SD card to copy over, and it's just a smaller form factor. Like smaller is, I think, always preferable in these scenarios. It's more discreet and less pieces to leave behind and forget to bring to the job site. So in terms of the camera quality, like right away you can tell that the colorization here is much better. The color range is also better. Like the dynamic range looks to be better. Is it the same laser head as well? Is it still like the XT16 that's on top of there?
The hardware, yes, it's still the same sensor, but of course the algorithm wise is much improved.
Right. And you're stating some accuracy numbers here. I like that they're saying, we're talking about 3 centimeters. We're not, breaking like the laws of physics when it comes to GPS accuracies. But absolute accuracies of like 3 centimeters, 3 centimeters relative. And this is assuming that you have the RTK on and configured and you're scanning with RTK, right?
Right, correct. It's for the absolute, yes. And then this is actually the accuracy that you will get directly from the real-time data. So it's already, in terms of use cases, if this is something that you already can use, then that's where the real-time data being usable right away.
Got it. Yeah, that's exciting. Real-time data being processed with GNSS, georeferencing, and all of that for absolute accuracy, meaning that there's, it's combining all of that, and then the map file that you get on the SD card is going to be georeferenced. Like it's going to be in WGS84. It's going to be on the elevation and whatever your base was. Cool.
Yeah. So as long as you attach the RTK, then we can do that real-time georeferencing from the real-time data. And actually, with the Ultra Pro, is now we're incorporating an SSD drive in there. So not SD card. So enhancing like the whole transmitting speed and everything.
Yeah, that's good to know. The one thing I also noticed is that you now are supporting just plugging in the device, like your iPhone to the device. That was one of my things. And with all these scanners, it's always like Wi-Fi based or Bluetooth based, and it's like it just kills the battery on my phone. And I often just avoid it if I can. But having it plugged in is just such a simple and elegant solution. So I'm very happy to see that that's coming on board. I see that we get a terabyte of storage. That should be plenty. Battery life, what do you kind of expect from that?
Battery life is still around 90 minutes, but of course the handle battery is interchangeable. So usually like 2 or 3, then that gives you a 3 hour or even 4 or 5 hours of data. That that's already a lot. For a single scan.
Yeah, exactly. Your forearm's going to be tired before your battery's out. And then the density, the 1 millimeter density, and that's what you talked about. Like now post processing can be other things if you want to do them. And you guys call this Lixel upsample. But what we're looking at essentially, this is still a colorized point cloud. It's just that the point density has been increased in post processing to basically make it look like a surface, like a mesh, essentially.
Correct. So basically, again, on the leveraging on the multi-slam side, we're adding more points as well from the visual side. So to support on the point cloud that the LiDAR actually get, and then kind of arrange them, align them better and down to a 1 millimeter spacing, so that you get a very smooth, a good surface essentially for the colorization. Now, definitely 1 millimeter is just a option. To get to that, you probably need a big processing power, but we also have the 5 millimeter option, which is still a very good results.
Yeah, and when I first saw this, I was like, why would you want that much density? But what you realize is that sometimes the thing or the area that you're interested in is further away from you, like vertically, like the top of this facade, and inherently that area is going to be much sparser in return quantity. And so it's about if you're gonna do feature extraction on these areas, and that's what matters to you, then this may be very useful for you to pick the better lines there, right? Because again, just like that example of me making that accuracy assessment from doorway to doorway with point clouds, one of the trickiest things is just being able to pick the same point over and over again. Because if there's no point there, you can't pick into thin air. So that it started to click after that. I'm like, okay, this makes a lot of sense. If you need it, it's there, which is a huge benefit, and it's not going to create a lot of storage implications for you otherwise. Cool. So it sounds like you guys have, for a fairly new entrant into this business, you guys have quite like a stable footing already. We have the hardware, right? You guys call Lixel. We have LCCs, your term for the neural radiance fields and the Gaussian splatting. Everything is, from my experience, like super easy to do, especially on the PC side of it. It's like 1 or 2 clicks, but also gives you opportunities for customization if you need it. You have a local viewer, right? You can view it locally, you process it locally, you can also share it externally online. I think you're going to be doing more with like the online portion of it. I haven't really seen much about this, but
Right.
that's always a great thing. But then one thing that gets me really excited is the SDKs and the plugins, and sort of bringing this into other software and other workflows for users.
Correct. So, we want to focus on, in terms of, the generation of the 3D content, so with the data collection and data processing. But, we want to enable the community really, and then the developers to really develop the final applications of how to use these kind of data. So that's why we are enabling, developing the SDKs for Unreal engines, for Unity platforms, and also for WebGL platforms as well. For those who are developing their applications and want to use the Gaussian Splats results.
Right. Yeah. We talked about this the other day, and we were looking at this one here, collision and relighting. And, I remember when NERFs first entered the picture and we were talking about them and the papers came out, I heard that Waymo had created like just a massive NERF scene of San Francisco, and they were using that for training, right? For training their self-driving car models. And that makes complete sense, right? But the reason that Waymo is doing that is because they can afford to do that. They have the equipment and the expertise to go out and collect that scale of data. It wasn't really until something like this is starting to become more available that would be possible for smaller businesses and startups to start to approach with their own problems. So I see a lot of very like unique and things we haven't really thought of in that direction as well.
Yep. And we're excited to see the new ways of leveraging and using these kind of data.
Yeah. These are really visually consistent with reality, and it's again, if you're going to be building what we thought of as the metaverse like 2 to 3 years ago, it's not going to be like blocky. I'm sorry, it's not going to be blocky little Minecraft figures walking around. Like no one's going to be into that. It's got to be it's got to be what we're used to. It's got to be as photorealistic as possible. Of course, we could be doing that with meshes, but that's just so difficult and so heavy. I think this kind of is, the genesis of what we'll probably see play out into what a metaverse really becomes. And I'm also excited to start seeing this in VR headsets. I have an Oculus behind me there, or a Meta Quest, and I can't see why. I haven't really played around with trying to get this to run on there, but I can't see why it won't, because it's a lightweight splat. It's a very small file essentially to render. So yeah, love the opportunities that this brings up for the use case. Okay, so just to wrap up here, we kind of covered everything that we have here. We talked about the hardware, the software, the data processing, collection, and applications. Let's open it up for some questions. I'm going to look through what some of the chat comments were here to see if we missed anything, and I'll pop it up here.
Sure.
Oh, Mindy's on the chat here. That is answering lots of these. This one's interesting to me. Do you have a technique for generating textured meshes from the same data?
Well, right now, not yet, but that's sneak peek. We are in the work of looking into this, because naturally we have all the data there. It's basically how do we actually use it and actually make it useful for the results.
Yeah, and I mean, if you want to do it yourself, you can. What you do get in the resulting files is the point cloud, but you also get the trajectory, and so that's actually all you need to generate your own mesh. Estimating the normals is typically the hardest part of meshing an unstructured point cloud. But if you're using a tool like Metashape, it allows you to base the normals on the trajectory. And so you can very easily create your own meshes from any laser scan, as long as you have a trajectory along with it that fits. It's a little bit more time consuming and hands-on. So it'd be great if you guys could just turn that into a little dial that we press. But It's not out there for sure. Let's see. I think we already covered this one, but sharing. So the splat and point clouds, offline viewers, you have the LCC viewer. There's no plans to like get rid of that or change anything about how that works.
No, we'll always have it available. The viewer is free. You can just download it from our website. And then that viewer, quick installation onto the computer, then you can view all the offline data, the .lcc format data inside the viewer.
Got it. I saw some questions here about mounting this to a drone. Have you guys tried that? Is that even worth it? How would that play out?
I think that's a that's a natural experimental way of doing it. We don't, it's not like the official way of doing it at the moment. Like you said, that the 120, if it's just the 120 meters, it's not that much of a range. And second is the visual camera on the side, and you're not actually getting the good enough data, right? Image data directly from the drone. What we are doing though is that we are adding new features to the LCC Studio, which you can add in the imagery from the drones, so the DJI drones, whatnot, and to train them together and to stitch them together. So that way, you don't have to bring up this big sensor on M350, but essentially you can still then get a good data afterwards.
Oh, so you're saying you'll be able to generate the LCC splat like the indoors with your K1 or L2, and then if you also want to have portions of that scene that are outdoors that you would have not really easily collected on foot, you could bring in data, like just imagery data from other sources and blend those together in one go.
Correct. So that's in the work. We still need some time to actually practice it. But we do see the demand of, naturally drones has the advantages of the drones data collection. So we want to, put them together and then to create like the full model.
That's really cool. That's really awesome. It opens up, just more flexibility, I think is the best thing to ever have. So I'm excited to try that out. Someone asked if the LCC will work like post shot, where you can just bring in image sequences. I don't think that's the case, right? Like your LCC solution is like for your hardware because it requires all of those other components to be there, the SLAM, multi-SLAM, the IMU. So it's not like a tool to make your own splats, essentially.
That's right. Yeah, it does require all the information. Actually, the scanner is, and with the camera, of course, it is collecting, and then it needs everything to kind of work together to develop the results that we have.
Yeah. Question here: does the software work on a Mac or is it PC only?
Right now, it's PC only.
That's usually the case with geospatial. Unfortunately, I was a huge Mac user before until I got into this industry, and now I can't use Macs for anything, even though they're great. Awesome. Let's see. I don't see any more questions that stand out. There's some questions about BIM and CAD integration. I think we covered that. At the end of the day, it's a point cloud. It's a geospatial data set, so you can definitely do whatever you need to do with it. We'll leave it there for now. Real quick, just for a little plug on my end, I'm going to be at the Drone Deploy Horizons event next week. So if you're going to that, please say hi. I have a session on Tuesday as well, and it's going to be all about ground level captures with cameras, 360 cameras, and scanners like this. And it's going to be a little bit more of a technical how-to session. Sunny, I think, is someone from XGRIDS also going to be attending Horizons?
We're working on the schedule. But we'll definitely say hi as well. We're there.
Yeah, it'd be great. I'm not going to bring one of these scanners there because I don't want to lose it because I have to give it back to you. But sure. I'd love to do a scan in Arizona and see what we can do in the desert. Anything on your end that you'd like to plug in before we wrap up here?
No, well, we are in San Diego right now. It is the last day of the Autodesk University. So if you are in the city, do come and say hi. We have all our scanners right here. So if you want to take a look. But yeah, thank you, Ted, so much for today. I think it covered a lot. Excited to see a lot more what can be done with the Gaussian splat results and the scanners.
Yeah, no, thanks for having us, or thanks for coming on board and doing this webinar. I know we talked about it for a while. I always love doing these and being as as technical as we can. And yeah, you didn't leave anything out. And I think if anyone has any questions, reach out to Mindy, reach out to Sunny directly on LinkedIn, reach out to me. I'm happy to answer it. And I'll provide some of the data sets that I showed today. I'll zip those up in a Google Drive and a message whoever asked in the comments for that, just so that you can explore them yourself. I'll even provide some of the LCCs, and you just have to go get the viewer and open them locally. So hope that everybody can have fun exploring those. Until next time. So take care, everybody, and be safe out there.
Yeah. Have a good one. Bye-bye.